All right, here's another example of solving systems of linear equations by graphing. So here we have a collection of dimes and quarters is worth $9.55. If the quarters were dimes and the dimes were quarters, the total value would be $7.60. Find the number of each coin. All right, so first we need to figure out what our variables are going to be. Well, it says find the number of each coin. So let's define our variables as the number of quarters is going to be Q, and the number of dimes is going to be D. Now let's write some equations because we know a little bit of information. So if, as the collection is right now, the dimes, the value of the dimes plus the value of the quarters is $9.55. Okay, so how do we figure out the value of the quarters? Well, 1 quarter is worth 25 cents. So 2 quarters would be 50 cents and so on and so forth. So we would just multiply the number of quarters by 25 cents. And that would give us the value of the quarters. Then we add that to the value of the dimes. Well, each dime is worth 10 cents, so 0.1 times each dime, so if you had 10 dimes, 0.1 times 10 would give you $1, which we know that's, logical thinking, so that's good to think that way sometimes. So there's one equation. Now it gave us this other equation that says if the quarters were dimes and the dimes were quarters, they would be equal to $7.60. Okay, so this one's a little tricky because let's think. If the quarters were dimes, so if the number of quarters actually had the value of dimes, so here's the number of quarters, and we're going to give those the value of dimes. We're going to say if we take the number of quarters and multiply it by the value of a dime, and then we add that to the value of a quarter multiplied by the number of dimes, we would get $7.60. So let's figure out how this is going to play out. Obviously, we need to figure out how many quarters and dimes we have. So again, we have 2 equations. There's a number of different options that would give you this. We could go through all different ones, $9 worth of quarters. Well, not quite because you couldn't get that in dimes, but there's lots of different options, and we'll see that on a line. There are lots of options that would satisfy this one. There's lots of options that would satisfy this one. But to satisfy both of them, we're going to have to graph them or solve them algebraically to find their intersection point. What's a point that's on both lines? Because all of those points on each line satisfy the equation, and let's find which point they share. All right, so here's our graph, and let's take a look at the points we need to graph. So again, we're going to look at our equations, and these are basically standard form, not quite actually standard form, but they're in that format that we could use cover-up method. So for this first equation, let's figure out its intercepts. So if Q is equal to 0, if I have 0 dimes, or 0 quarters, and just dimes, I cover that up, that goes away, and I have $9.55 divided by 0.1, which comes out to 95.5, which isn't feasible necessarily. That's when we're going to get into that discrete and continuous argument, but let's just, for argument's sake, say that we could have 95.5 dimes. And then if dimes is equal to 0, we have 955 divided by 25, which comes out to 38.2, which is going to be right about there. Oh, we forgot to label our vertices. Okay, so this first one was when quarters is equal to 0 dimes. So this one's going to be dimes, and this one's going to be quarters up here. Okay, so we have this line. Let's go ahead and graph this line. And again, any point on this line, hypothetically, makes this equation true. Now let's graph the other one. If we use the cover-up method for this one, when dimes is equal to 0, when dimes are equal to 0, quarters would be equal to 76. We're going to come up here. And then when quarters is equal to 0, dimes are going to be equal to 30.4. Barely right there. All right. And there, now again, we've talked a little bit about solving algebraically for some of these is definitely the way to go if you want a super precise answer, but this graphing gives us just a really good visual of where they cross, and you can tell where they probably are going to cross. They're really, really close to each one of these, and so we can see that we're just right above the 30, so let's call that 31 on the quarters. And we're just before 20. That looks like about 18 to me. And so right here, this point is 1831. So that means that this point, 1831, satisfies both of these constraints. So for this line, it makes sense. It works. If I take 18 dimes and 31 quarters and add them together, it's going to come up to 955. And if I switched it and took 18 quarters and 31 dimes and added them together, they were going to come up to 760. And so this point right there is the exact same for both lines, and that is our solution.